Good morning. Thursday, and tomorrow Friday. When I was younger, I loved to play, build things. So let's play. Yeah, it's not so much time. Let's play quick, yeah? Let's try to design and build a switching power supply. How hard can be, okay? So what I'm doing now, I done no research, so don't think, oh, I search. No, 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 nothing. Yeah, that's what I was doing around 25 years ago. Yeah, was playing with these things. Let's build a switching power supply. Yeah, and let's see how simple we can make it. Yeah, shall we? Yes. So I will search for a board, a TV board or whatever board is. I just need a chopper. I have some transistors from an old audio amplifier, and we can build something quickly. But that should be quick, like 5-10 minutes. Yeah. Let me have a look. So which chopper we should use? Yeah. Okay, this is the input. No, on the input we need one more for the transistor reaction. Oh, this is not a power supply. No, not this one. Oh yeah, this one will be perfect. Yeah. So let's just build a switching power supply. I know I have here. Yes. So look on this. You saw before, they are made. These things. Look, these are transistors, not MOSFETs. Before the things was proper made. So these are pairs. PNP and NPN. NPN, yeah? So let's quickly build a switching power supply. That's fun, You know how much fun you can have? I will explain you after why I was building these power supplies, yeah? Okay, let me grab the solder iron. And let's start. It's a quiet day, so I think I can afford playing a little bit. I should be quick still. This will be long. How can I take that transformer out quickly? This is, I don't know, it's a random board from some TV, I don't know which TV, and obviously it's dead. It's for spares. So you can use probably any transformer, but you have to tweak the one resistor. I will show you. I will explain you. And here you have the output. I think here is the output. Resistor and ground. Okay, it is the output. Obviously we need the input, we need the output. We need a high transformer, high frequency chopper transformer. Yeah. So this will be fun. Okay, I just need the position because on the primary I have two coil, yeah? Coils? Yeah, two coils, probably, yeah, that's... It's not right, 2 coils. The English is killing me, you know. Let's check with the multimeter. Continuity. So this is the high voltage one. Yes. Okay. And here 1 ohm. That's great, that's fantastic. And this one, I don't really need 8 ohms. Well, I don't really care, you know. Okay, let's see the output. Output. What do we have on the output? Hmm? Only this? Wait. So this is the output. These two? No, these are doing nothing. This is one of the outputs, so the last one. Wait. With these two. So these two. So I don't understand. That's the output, yeah. And here, that's a diode who comes from. Diode comes from this pin, the last pin. And this is ground. So this will the last pin with this. I think I just found the problem on this board. This is crazy. How is possible? So actually this has an issue. This is the problem on this board. We still have half coil here, good. No. I get it now. No. Okay, now. So to make this working, we have to put these two together. No, I get it now. And these two together. Okay. Yeah. I'll try on the end, but let's do it together. I'm so sorry it's not a live stream. Because, you know, I have many emails about, you know, the power supply looks like it's the whole holy grail, you know, it's looks complicated, but I'm not. Actually, are very simple. And now it's fine, yeah. Okay. That's great. What do we need on the output? We need a diode, obviously. Let's sort up the output first. We need a switching diode. And a capacitor. We'll try to use a high voltage one because I have no idea which is what will be the output, or maybe not. 35 volts, I don't think will be over. Obviously you understand, there is no research, no nothing, we just build a power supply and we are building a power supply and it's not tweaking, it's no research, it's no optimizing, it's just basics. Yeah, let's see if the capacitor is working. Power supply, variables plus minus. Yeah, spark. Spark. Okay, looks like it's working. Yeah. Okay, so the output is here. Good, good. That's my diode on the output. And we have the capacitor plus minus. So minus will be here. Minus plus. Yeah, so in this way you understand what I'm doing. Good. And we need something to see if the power supply is working. We need a LED. 1 second. I think, yeah, we have some LEDs here. Okay, let's see if this is working. Plus, minus. Hey, it is working. So minus is here. Minus. Minus. This is minus. Minus. Now I need a resistor. For 400 ohms, something like that. For 100 will be fine. No, really. Let me try to find another one. We need a 100 ohms. No 100, around 400 will be fine. Yeah, no. Not this one. Two two zero, huh? Or maybe not. 110. Let's see. Let's check. 1.4. Okay, I was wrong. You know what? $178. Okay, that's good. Leave it like that. Okay, from plus. So on the output we have a resistor to the LED. Yeah. Let's see if it's working. Yeah. Power supply. Let's see. Let's say 5-6 volts. Plus, minus. Yeah. And you have light. Okay. So it's working. Next. Yeah. We need the transistor. These ones I think is base, collector, emitter, but let's check. Diode, base, yes, yes. Okay, so this is the base. This is the collector, base, collector, and emitter. That's good. Let's solder this one. Collector there. That's the emitter. Let's check with the power supply, yeah? So that will be minus, and this plus. Yeah? Yes? Oh, 1 second, yeah? Okay, I'm really sorry. What is my thing? My switching power supply. Okay, let's see, yeah? So this is the emitter. If this is the emitter, and this is the plus, that means when I will short the base with the collector, will be in short. Yeah, it is in short. Yeah, when the transistor is open. Okay, that's great, that's fantastic, yeah? What do I want to do now with the base? The base. Okay, I need a resistor, 1 second. Let me search a resistor. Just be patient, I'll do schematics on the end. Yeah? That's 0. That's not good. $100 ohms, 150 actually. Maybe a different one. Let's check with 100 ohms, yeah? Maybe it's not 100 ohms. Let me check ohms. Ohms. I don't understand. When I learned when I learned the a lot of time ago, yeah, the color codes, yeah, you have brown, green, and brown. That's mean 150, 150 ohms. But look like this is 4 ohms. The things get changed, and I don't think I like the changes. Hmm? 102. Okay. Adjustable resistor. That's good. So we can adjust. This was supposed to be a quick thing. Now it's taking too long. You can't find a resistor in these days. So everything is SMD. I don't want it. I want a normal resistor. Can't believe. What should I use to find a normal resistor? What should I use? Okay, let's use a small one here, because we can't find a normal one. Yeah? Okay, let's find one. 50 ohms. So this one. What about this one? No. But anyway, if you are doing these things, you know, you should have spares. It's okay, but you understand there'll be a charge on this thing, yeah?
I know the last
Okay.
time,
Yeah, but will be a charge this time. Last time I didn't charge you.
No, you charged me the
No,
last
no,
time.
no. I remember for software I didn't charge you. No.
Ask him, the boy that carried the bag, yeah?
I'll ask you.
Yeah.
Okay, thank you.
But are you going to finish it today?
Yeah, around 5
Can you
o'clock,
make
yeah?
everything, like, new,
Yep.
like...
Yeah, we can. It's £60. Just tell me, and I will install the Windows and the software.
Leave that one. Just send me to the
Okay, I'll leave it.
CDs inside. Yeah?
Okay, thank you. Some people are incredible rude, you know. Yeah, I suppose that's the life. I don't. What? Okay, I found one. Yeah. Again, brown, black, black. What does it mean? 100 ohms? No, it's not 100. Probably it's 10. Yeah, probably it is 10. But this is sick. In these days, you can't find a resistor. I can't believe. Okay. Ten ohms. 471, that's mean 470 ohms. 81. Okay, you know what? Let's take this one. Let's see. This one. Yes, that's the one. Okay, finally. Finally. Base. Okay. And we have this one. Actually, you can adjust whatever value we need. Yeah. That's all. Wait, I need a wire. 1 second. We need a wire from here to the plus. That's the plus. We can even use a capacitor, but we don't need a capacitor. That should be fine. Let's check now. Minus. See if it's working. Yes. Plus. No, it's not working. Not yet. Okay, that's good. Maybe we have to spin these things. So now maybe it's 100%. So I have to twist this to this. Okay. Why is not working? Hmm? So we have 6 volts. Well, nothing happened. What I'm doing wrong here? Hmm? Hmm. I think I know what the problem is. think I need a cap. Yeah, I'm wrong. Hmm.
Copy that one. 19619219.
Hmm? Sorry. Okay. Probably I forgot things, you know. Well, Maybe I forgot things. You know what we can do? We can do something else. Clear, I'm getting old. Okay, so it's working. Yeah, I forgot things. Ah, I think the other two pins are acting like you know, are generating voltage there. Obviously, if you don't work, you forget things. You understand. Okay, so this is a switching power supply. When it's working. You can optimize the power supply. So we have 6 volts. We can go lower. Let's see. 3.3 volts, yeah. And on the output we have. Let's see what we have on output. On output we have 14 volts. Yeah. So you can see 3.3 on the power supply. So that's the input. If I check here and here, yeah, 2.9 volts. Yeah, you can see. Plus minus 3 volts. Yeah, so that's the input. The output 14 volts. Yeah, you can see that. 14. And that's our look, it's working. Yeah, that's a switching power supply, yeah. I'm really sorry, it was a little bit too long. Yeah, okay. Let me get closer so you can see exactly what I did, yeah. One second. You can't really see. But anyway, that's the output. The LED is still on. We have a diode, have a cap and a resistor to the LED, yeah. And on the input, we have the adjustable resistor with a cap. I have no idea what the value is the cap. You have the transformer, which I have no idea how the wire is inside and how many things are. And we have a transistor. It's a big transistor. But that's how a power supply switching looks, yeah? It's still working. But this resistor is getting hot because I wasn't thinking the output will be like 14 volts. And on this output, on the other output, but I don't think will work to check. Volts, AC. We don't have AC? AC, yeah? Let's see what do we have here. Here should be a lot more. No, you can't check. Yeah, but it's doing sparks. Oh, my GoPro frozen. Yeah, I was thinking that will happen. Okay, so this on 3.3 is taking out 14 volts. If I go up 5 volts, yeah? Let's see what output do we have. Sorry, DC volts. 1 second. 21 volts, you can see there. 21. 1 second. Okay, let's go low to see what we can get more from this power supply. 2.3 volts. Even low. 2 volts. Oh, this is quite good. What? How low I can go? 1 volt. So the power supply now is 1 volt, and on the output we have like 3.7, huh? 3.8 volts. That's good for 1 volt. 1 volt, yeah. And I think we can get more. Let me adjust this one. We can get more, yes, definitely. Yeah, let's check now the output, yeah. And now the output is what? Ah, sorry. Here is the output. 5 volts, 5.5 with 1 volt input. That's beautiful. So from 1 volt we can get out 5 volts. Even less, even less. Let's see. 0.6 volts. And on the output we still have like 3 volts. That's good with 0.6, yeah? Let's say 1.5 volts. How much is a battery? Yeah, 1.5 volts. And on the, oh sorry, this is moving. This is moving. And the output is 8 volts. 8.2 volts with 1.5 on the input. That's good. Yeah. So let's go a little bit through the theory, yeah? The theory is paint. Let's try to schematics. So you have like that, yeah? What happened? Oh, sorry. Something like that, yeah? And we have the transistor, yeah? Come on. This is a NPN transistor, yeah? This is ground, minus. And here we have the transformer coil, yeah? Here we have, you know, 1 hour wire from the transformer coil. From the coil of the transformer. And here we have the plus, yeah? This is the plus. Plus. From here, what do I use here? What do I use? We have a resistor, adjustable one. I use a 470 ohms resistor, yeah, and this go here on the base. What happened? 1 second, that's not my day. Okay, I'm really sorry. So we have the resistor here, yeah, And on the other side we have the coil, yeah, and that's ground. Here we have a diode, okay, and from here we have a capacitor, minus plus to ground, yeah. And what do we have more? We have a LED. No. Then we have a resistor, 170 ohms resistor here. Yeah. So that's the my switching power supply. Yeah. I'm really sorry. It was quite long. I know it was long. And obviously the transistor is auto oscillating based on these things. Yeah. And you can't really control the many things, you know, but it's still working. And they are still using this simple it's an inverter, yeah. Especially, you know, the teasers, you know, the things with the sparks, yeah, they are using a schematics like that, but here you have, it's a huge coil and the output is around 5-10,000 volts, yeah. Yeah, I was playing with these things. I was playing when I was a little boy, you know, like I was 17 years old. And if you remember the old TVs, the black and white old TVs, they have a transformer, a big one. One side you have the high voltage coil. Sorry, 1 second. Yeah, on the old TVs you have the yeah, you have one coil, the high voltage one, which is the output was like 18 kilovolts, and after that you have a big diode to change from AC to DC. And you have the primary, and the primary, you can take out the primary and you can make your own coil. If you make your own coil, just use using this way 15 spinnings here, 15 1 5 and 15 here, yeah, it should be fine. Okay, but these schematics, you know, even let's say, yeah, on the output, yeah, if you use a big coil to generate out like 2-3,000 volts, you can use a light bulb, you know, you can light up like a tube. Yeah, you can light up a tube with this thing. Or you can do a lot of things. Or even you can use it like a, it's an inverter actually, yeah, a switching power supply, which is in this case it's an inverter. You use low voltage and the output is high voltage. It's an inverter. It's a basic one, simple. You can't control too many things, you know. If you want like if you want a protection, yeah, like short protection, you can use how many TVs they have? They have a resistor here around half of ohm, 0.2, 0.3 ohms. And from here you can come on the base of another transistor, same NPN, ground. This is pointed outside. This is a NPN transistor. And here, yeah. And this way, when you have a short, the current flow is like that, yeah. The current will get high when here this point will reach 0.6 volts. This will be open and will short the base to ground. So it will short this to ground. So that's how you can protect against shorts. If you want to have like a controlled voltage outside, it's more complicated because you need an opto device here to take a signal from here, so this circuit knows what happened on the output. It's more complicated, yeah, like how many TVs and many power supplies are. A little bit more complicated, not very complicated, but usually it's better to use like a chip. Okay, hopefully you understand how these things works. I used to have a oscilloscope to see some signals, you know. Yeah, it's not here anymore. Okay, so that's what you can have fun just building a thing. It is a switching power supply, and you have signals, you have waves working. Okay, thank you for watching. Like and subscribe if you like the video. It was long. This was supposed to be at easy things, but you know what I miss? I miss the cap. I forgot about the cap. And I go online and I checked, and yeah, should be a cap there. See you later. Bye.